Let's now look at the Kubernetes cluster creation with Microsoft Azure. There are a couple of options through which Kubernetes clusters can be created. One is, of course, through the portal itself. That is what we are going to see. There are other methods like through the Cloud Shell you can create, but we'll use Kubernetes services because it's a GUI option. GUI is much easier. So instead of doing that through the command, let's do it with the GUI version, and then we will then get into the Cloud Shell and then progress further. So the first step is create Kubernetes cluster. So we'll create that. So, and again, let me choose whatever is available, demo 1, and then I will say AKS1 is what I'm going to use. I've used earlier, so I'll use that. So the next one is the region. Sometimes US is not available, so I'll choose the Australia one. And again, here if you see, auto scaling depends on the account. Currently I'm using a free account. Auto scale is very important feature as far as Kubernetes is concerned. That is what is not available as far as Docker is concerned. Even with Docker Swarm is what you can actually compare. If you if you remember our earlier discussion, Docker Swarm is what you can have multiple nodes, and the multiple nodes can work together forming a Docker Swarm. But the challenge is about the auto scaling. It cannot, when you need additional nodes, Kubernetes can do that, whereas Docker Swarm you cannot be done. And similarly, on the scheduling part, it is also not there. So you got to get into the manual. I'll do 2 nodes because if you say auto scale, actually review create, if you're having a free account, it was giving out an error. So we'll choose manual. The rest of it is actually it's all, if you look at the node pools, it's all auto populated. You don't need to really worry about that much. I mean, from a development or understanding standpoint or learning standpoint, you don't need to worry much on that. So maximum quota is select one, selected 2 course. Here it is giving an error. So let's try going into another let's say Europe. Let's see what happens. And still it is there. So maximum node count you can select is 1 due to remaining quota selected in the subscription of 2 cores. So that is because of the subscription. So we will try redoing it again. Sometimes when you try redoing it again, it goes. So let me discard and try doing it again. Free service and demo 1, and again I'm going to say AKS 01. Then let me choose the same one, and I'll say 2 nodes. It's going to be manual and 2 nodes. Okay, as we see, auto scale. So the error has gone. So most likely I had on the same resource group, I had a couple of virtual machines also running. So that's where it had a limitation, and particularly because it's a free tier, it was not accepting. So I have just stopped the resources. I mean, resource in the sense the virtual machines I have stopped. And additionally, I chose another region, UK South. So once you give the cluster name and the resource group, I think we are all set. Let's try to do a validation. So the first step is it will validate, and then if validation is successful, then only you'll be able to proceed to create. So validation is successful. So now we will create the Kubernetes cluster. So if you see that UK, this is the name of the cluster, and resource group is demo 1. So we'll say create. This takes about approximately 5 minutes to get created. So let it create, and once it is done, we'll get back. Yeah, now the deployment is complete. Deployment in the sense, we have the cluster. The Kubernetes cluster is there. It's a bare cluster. Nothing else is there. So you can go over to the cluster, and it gives all the details. It says succeeded. The cluster name is AKS1. AKS01 is the cluster name, and it's on demo 1, and AK01 is the name of the cluster. Resource group is there. So we need to progress further. We need to, in the next session, we'll be using the Cloud Shell. From now on, we'll be using the Cloud Shell to interact with the Kubernetes cluster and create the application. Thank you. Stay tuned. Welcome back. Now that we have created the Kubernetes services in the Microsoft Azure, that is the first step. And after that, you need to create the appropriate nodes with pods, and then get into the deployment and have the services so that the Kubernetes cluster is up and running. So to do that, we'll be using the Cloud Shell. So in the top, you have the Cloud Shell on the top menu. So click on Cloud Shell. So it'll connect into the Cloud Shell. It is something similar to the virtual machine Linux command line commands, but this one is with a Cloud Shell. When you connect first time, it's going to take some time, and post that, once configuration is done, it's pretty much fast. So we have to first configure the Kubernetes. So there is a command to it. We'll see that. The first step is, as I said, you got to configure the kubectl to connect to the Kubernetes cluster. So for that, you need to run this command AKS get credentials. This command needs to be run. So we will run that command. So paste it. So whatever is the resource group, I have used demo 1, and then I have given my name of the cluster AKS01. So I'm running it. So earlier I have given with the same name. That's why it's asking whether it can overwrite. Say yes. And again, the cluster, whether that can be overwritten as well. Say yes. And it is merged. And so this is the configuration file. So if you want, you can take a look, but be careful not to change that. So all you need to do is nano dot cube/config. That will open the file. So whatever is the configuration file, it will open up, but ensure that you don't make any changes. So I'll just exit it. So Control X. So I'll say no. So no changes I have made. So it is just for reference. This is where all the configuration is going to be there. So we have now got the credentials. So we will progress further. I mean, if you recollect earlier, we just created Nginx and Docker and opened the ports. And with the Docker, once it is the Docker container with the image is up and running, when the port is open up, you can you can access it from the web. So the first step, we'll attempt whether it is possible with Kubernetes, whether we can, once we have a pod with image of Nginx, whether it will be accessed from the outside world, whether it is possible. We'll see that and then progress further. Thank you. Stay tuned. Okay, let's progress further. Let's first get the nodes. kubectl get nodes. Command is so there was additional space in between. So kubectl gets nodes. So if you remember correctly, during configuration we said 2 nodes. So I mean, when we did through the portal, we said 2 nodes during the configuration. That's where it has 2 nodes. and whereas pods, that is kubectl get pods, if you look at that, there is no pods as of now. Now let us, if you recollect, just like Dockers, let's have the Nginx in one of the pods and see what happens. Whether if you refer to the earlier discussion, we discussed about deployment and services. So let's have in the pod, let's have the image of Nginx. To do that, so the command would be this one, kubectl run nginx images. This is just like sudo docker. We pulled up the nginx image in case of Dockers. Here in case of kube, we are going to have this one. So it says it has created, nginx has created in the pod. So we will just see get pods. So you have pod up and running. But if you look at the services, because you need to have a deployment and there need to be a services. If you recollect our earlier discussion, the services is what is exposes it to the external world. So we say get service. So this is a Kubernetes cluster IP is just for the Kubernetes to up and running, only for that. So you don't have an external IP, an exposed IP with the Nginx. So that is the challenge. You need to have a deployment in place and you need to have the services in place. So even the deployment and services is not available, whereas you have a pod up and running. So it is just an isolated pod with Nginx, but you cannot access. You need to have deployment and service, and that is where you need to have, just like in case of Kubernetes. In fact, it is an orchestration. You need to have just like a Docker file, and in case of Docker Swarm, you'll be using a YML file, and similarly, in case of Kubernetes as well, you need to have a YML file, and wherein you ensure that a deployment happens, and the deployment links with the services, and services is what gets exposed to the external world. So that cycle needs to be completed, or that loop need to be completed. That is you need to have a YML file, and the YML file ensures it has all the details as what needs to be deployed on the nodes, that is on the pods as well, and then the services needs to be up and running, and services provides an IP. The external IP will get populated, and the external IP is what will get exposed to the outside world. So we need to delete the pods, this pod, because we need to release it. So the command is kubectl delete pods and nginx. So this is to delete this, because this pod is not needed, so we will delete that. So pod is deleted. So this pod we have deleted. So we'll, in the subsequent presentation, we'll see about the YML file. There is a structure in which the YML file needs to operate. We'll see the structure, and then this needs to be moved into the Cloud Shell, and the Cloud Shell, from the Cloud Shell we have to ensure that the deployment happens, you have a service, and so that we can access the Kubernetes cluster from the external world. Stay tuned. Thank you. Let's now look at the YML file. This is similar to the earlier we saw the Docker file. In fact, YML file is also used in Docker Swarm, which is something like Kubernetes, but it is not that flexible like Kubernetes. So there also we use YML file. So if you look at what is a YML file, all Kubernetes objects should be described in manifest, and that's called the Kubernetes YML file. It is something like a configuration file, as what is that image it needs to take. It has the deployment details, it has the service details, So that is what is being said. These YML files describe all the components configurations of the Kubernetes apps and can be used to easily create, destroy your app in the any of the Kubernetes environment. So you apply, when you do an apply, you can use the create command to create it, or you can use the apply command, and then you can also destroy it or delete it using the YML file. So if you look at the structure, this is how the structure is going to look like. You have the file, you can create it as a separate file, or you can, in the single file itself, you can have deployment and services together, and then you have a metadata and the specification. The specification is particularly the important one is replica. When you want to have it with two nodes, or whether you want it with a single node or many nodes, you specify this in the replica part. So that goes in the spec. Template refers to the pods, and that is where you have the images coming in. So all this constitute the YML file for the nodes. In the nodes you have the pods as well, which has the images. And then on the services side, critical one is of course the name, and then you have the port details, so that it can be, because services is what is available to the external world. So that is where you have a port mentioned there as well. So I'll show you a file, the Nginx file, that gives a better understanding as well. So this is the Nginx file. The first one is kind will give you the deployment in the top, and then we have a services, and then replica tells deployment to run, and this is for two. Actually, it should be two deployment to run in two pods, because it is two. It needs to be chained as two pods, matching the template, and template is refers to the creates pods using the pod definition in this template. So basically, the details for the pod creation is based on the template, and that is where we are going to have the image as Nginx, label as Nginx, a name as the container as Nginx. Then comes the service. We use what is the protocol, what is the port which is being assigned, and the load balancer is all what nodes, and if node fails, what needs to happen. So all these informations are there in the YML file. And now that we have Kubernetes framework up and running with two nodes, you need to use the YML file and apply it. Then yes, deployment happens, and then the services happens. Services happens in the sense it gets created, deployment gets created, services gets created, and then Nginx is available to the external world. So we'll see that how to progress in the subsequent presentation. Thank you. We will use the YML file now to have the deployment and services created in the Kubernetes cluster. I have two YML file. First, let's have it with the Nginx. So if you look at cat nginx-ds.yml. So basically, it has the deployment part. It has the template. We have replica. We have stated two. The template is for using. We are going to have the Nginx image and then the name as well. And similarly, services. We'll have the metadata part, and then what is the port we are going to use. So we have the YML file. We have going to use the command. There is an apply command to have the deployment and services created. So this is kubectl apply -af, and then the file name, which is nginx.ds.yml. So So this the deployment and services of Nginx is done. So kubectl get pods. So this is Nginx is up and running because we said two two replicas, so you have them. So kubectl get deployment, spelling is wrong, kubectl get service, and we have the, now you'll see the IP address. This is the external IP address, so we can use that. And similarly kubectl get deployment. So Nginx up to date, available, up and running. So deployment is done, the services is done. So we need to use this IP. We need to use this IP and check whether the browser has the whether we are able to get the image of Nginx. So we'll see that. Yeah, in the browser I give the IP address, so that is 20.68.185. that is automatically assigned by the Kubernetes cluster master node. So that IP address, when we have that in the browser, we have the Nginx web server information. The page opens up. So we will also see kubectl get nodes. So we have two nodes up and running. We have the pods with the images, we have deployment and services. So deployment has to happen and services needs to happen, and then we are provided with the external IP. So that is where we need to have the YML file which acts on the, which gets the information from the template, and then pods are created, and then we have the nodes, and then it uses the services with the ports, and the ports is opened up so that from the external world it can be accessed. So I think it is now pretty clear. Like you can also you can delete it. Kubectl, you want to remove it, you can also remove it. Delete -f nginx -ds.yml. So you can also delete it from the pods, and similarly when you apply it with the YML file, based on the information which is there in the YML file, the deployment and services happens, and you can also delete it. Instead of applying direct apply, you can also create one by one, if you have the deployment file and the services file separate, and then you can also create them. So this is the simplest one. Next we'll take up, in fact Microsoft has also have a small application wherein they have the backend and the front end, kind of a quiz kind of a setup. We'll see that in the subsequent presentation. Thank you. Stay tuned. There is one more YML file definition which Microsoft themselves have provided with a kind of a voting application. So we don't know like what is that, because it's an image. We don't really need to bother about what is the coding behind it, but we look at the deployment. The deployment has two parts. Deployment and services is there. One is uses the Redux Redux is a kind of a on memory database. It uses the Redux, and then which is the backend part. Azure Cloud is the backend part of it, and then you have a front end as well. So there is also a front end. So you have a backend part, and then the service of the backend. If you look at it, there's a back, then Azure Cloud front, and you have the Cloud front. This could be, so we are taking only the image. So this could be the image could be, if you remember right, we try to build in the Dockers, we try to build an image with just a print command. So similarly, this image, this is an image. Inside it, there could be any code. It could be a Python code, Java code with a front end in it. So we are not bothered about it. We are taking that, just that image, and try to deploy it. You just need to take the code and deploy it. So you can look at the URL, or if you don't have the URL, I have that in the resources section. This code I have copied into the resources section, so you can use that and deploy. So we'll see what happens when we deploy. I mean, you need to have the YML file, and then um, on the command line you need to apply. So you need to have the deployment created, front end and back end. One is related to the deployment back and deployment front, and services also. There need to be two services, and then in the services you'll have the URL from where you can access the application. So we'll see that. So I have, after deleting the old one that is related to Nginx, there is no services over here, and there is no also deployment, kubectl get deployment, there is no deployment there. So I had copied it. Azure vote is the YML file. If I say cat Azure vote .yml. So I just basically copy pasted whatever is there provided by Microsoft in their website. So we need to say now kubectl apply -f. Then the file name is what we need to provide, vote.yml. So we need to have the deployment done, both the back end and the front end of the deployment, and then so vote back is created, and then the services of vote back is created, and then the deployment front is created, and services of the front is created. So kubectl get deployment. So you have front 2 is running, and then we'll see kubectl get services. So this is the external IP. So we need to use this external IP to access that. So we will see that we'll copy this and then paste it in the browser and see what happens. So we have the application up and running. So if you click on cat, it goes to the backend, and that is where it gets backend in the sense Redix DB, the online memory DB, and gets calculated. So how many ever times you click dog1, dog2, cat. So you can also reset it. So it all depends on the code they have. So we don't know the code. We have just got the image from the whatever Microsoft is referring, and based on the image we have deployed it, and the services is there, and because the services with the port getting exposed, we are able to access from the external world. So I think now you have a fair understanding as how Kubernetes works. You have you might have multiple nodes. If you want, you can have single node, you can have a replica, you can have 2 nodes or 3 nodes, and with the pods, which is pods has the container, and the container has the images, and you need to have the YML file, and based on the YML file you need to make the deployment and services, and the services is what is going to access from the external world. Hope now you have a fair understanding on the Kubernetes. Thanks and stay tuned.